But because of preemption, all different processes, it gives an illusion to the user that all of them are executing simultaneously. But in fact, they were executing at different point of time. Why? Because you have only one processor. Parallel execution is only possible if you have more than one processor. So it is possible to execute multiple processes on single processor system or on multiple processor system. But what is the difference between executing a process on uniprocessor system and executing multiple processes on multiprocessor system is this. In uniprocessor system, assume that I want to execute 3 processes. On uniprocessor systems, I want to execute 3 processes, and on multiple processor system, also I want to execute this same 3 processes. Okay. Now, because this CPU utilization line, I have only one CPU here. Okay. So if I want to execute process P1, it means I will take the CPU time from this duration to this duration. Okay. When I want to schedule another process to the same CPU, I cannot use here. Why? Because at this point of time, the process P1 is already taken up the CPU time. Now I have chance to allocate another process P2 only beyond this time. Okay. And process P3 can be executed only after this point of time. So it can be executed from anywhere in this point of time. So P3 has provision to execute in this time intervals of CPU time. Now here, because you have only single processor, the time of CPU is shared between all of these processes. This is called process interleaving. Okay. Process will be executed on a single machine by interleaving. But to the user, they give illusion that as they were executing they are executing parallelly, because this thing will happen so fast that we generally will not distinguish which process executed first and which process is executed taking some time, because all this happens in milliseconds and microseconds. But whereas in multiprocessor system, the thing is, we will have different CPUs. There is only one CPU, and the one CPU will be shared across all these processes. But when you come to multiprocessor system, in multiprocessor system, process P1 can execute in this time duration, and process P2 can execute in this time duration, and process P3 can be executed in this time duration. Now, when I draw a perpendicular line here, so I'll get 2 overlapping. So in multiprocessor system, the execution of processes will be overlapping. They may overlap, but whereas in uniprocessor system, the execution of process will never overlap, because we have only one CPU. Process interleaving is possible in uniprocessor system. In multiprocessor system, execution of the process may overlap. Okay. Now, moreover, in multiprocessing system, you have multiple processors, and all these processors have been divided into 2 different categories. One is symmetric processing and another is asymmetric processing. So let us see what do you mean by symmetric processing and what do you mean by asymmetric processing. So all processors are classified into the following categories. So one of them is symmetric processor and asymmetric processor. What is the difference between symmetric processing and asymmetric processor? In symmetric processor, all are same. Okay, there is no level between one CPU and another CPU. All are at same level. They work in peer-to-peer basis, meaning there is no kind of master and slave relationship. Every processor can talk with another processor. All of them have right. They are equal. So there will be an equal load on all of them. Equal load on all of this processor. And a symmetric processor, there is no hierarchical level between any of this processor. There is no hierarchy between the processors. And in all the multiprocessing systems, main memory, that is the memory of the system, and its clock are shared. Clock and memory is shared. All of them are shared. But in asymmetric processors, there exists level of hierarchy. Okay, if out of n number of processors, you'll have one as a master processor and remaining are slave processors. So master and slave relationship exists among the processors. And second thing is, it's not necessarily that each and every system should have equal load. Okay, load will vary from machine to machine. So in asymmetric processor, all the n-1 processors which are not master, they are all computing machines. They don't run operating system. They don't have operating system. Right? The operating system will be executed only on the master, and the master will dispatch the work to different processors for computational purposes. But whereas in symmetric, yes, this is very important point to remember. In symmetric processing, each and every processor will run its own copy of CPU, its own copy of operating system. So every processor will run a separate copy of operating system. But whereas only one copy of operating system will be there, and load is also not equal. And there is, of course, hierarchy exists, master and slave, and clock plus memory is, of course, shared because it's a multiprocessor system, right? Now, if I asked you one question, that if a system has n number of processors and n number of processes, then in multiprocessing system, you tell me how many, suppose there is m number of processes. If a system has n processors, meaning n CPUs, m number of processes, which are jobs. Okay. So in multiprocessing system, how many number of maximum processes I can run simultaneously? So in multiprocessing system, the maximum number of processes I can run simultaneously is n if m is it's n, which is equivalent to number of processors, right? Or the maximum number of processes that I can run on n processors could be m if m is less than n. Meaning, I may have few number of processes. A system can have only 2 processes to be run, but it has 7 processors. So at that time, the maximum number of processes I can run will be only m if the value of m is less than n. If the value of m is greater than n, then I can run at most n number of, which is equivalent to number of CPUs in my system. Okay. So this is what the architecture has been changed from earlier, which is time sharing system, and now the multiprocessing system. Because the architecture changes, operating system also changes. Why there is dependency on operating system with the architecture? Because we know that in the very first class we have seen operating system is nothing but it's a system management software whose focus is on operation of machine. Because its focus is always on operation of machine, so if the architecture of the machine changes, then of course the coding for operating system also changes. The operating system also changes. So if the architecture changes, we change the operating system. The same operating system doesn't work. The operating system which runs for uniprocessor system cannot run for multiprocessor system. So change in architecture requires change in operating system as well. Then we have distributed systems. What is the difference between multiprocessing system and distributed system? In multiprocessing system, this system will share clock and memory. That's why they are also called as tightly coupled systems. But whereas in a distributed system, what do you mean by distributed system? The name itself reveals distributed. Okay? It is the ability to distribute the computing to different processors, different systems. Okay? Called distributed system. In distributed system, because each and every the computation is given to different machine, so every machine will have its own CPU and own memory, own clock. Okay? So clock and memory is not shared. Clock and memory is not shared, but whereas it is shared. That's why they are called loosely coupled systems. And moreover, the distributed system is not a computer network, because in computer network, whenever I want to do any operation like transferring a file and all, so I need to know the IP address. I need to have information about the architecture of network, and I need to have some information about the network. But whereas distributed system doesn't needs any information about the network. It is like your distributed system is nothing but a network plus all the network issues are transparency. This is called distributed system. So the operating system which runs in distributed system is different. Okay, distributed operating system, and computer network will have computer network operating system. Multiprocessor system will have multiprocessor operating system, and single processor system will have that operating system, which can manage, which can run on only one CPU. Okay, if you are changing the number of CPUs, the same operating system doesn't work. Okay, you need to change the operating system as well. So when the architecture changes, operating system also changes. Then at last we'll have a real-time operating system or real-time systems. So real-time systems are those systems which works on strict deadline. Okay, if I'm expecting input on that time, then the same input, if it has been generated after the time has been elapsed, then the same output or the correct output will be treated as wrong. Okay. To give an example, if 5 plus 2 is 7, okay, this 7 is correct before the deadline. If the same answer is given 7 after the deadline, then this output will be considered as wrong. So real-time systems are the systems which work strictly on deadline. Generally, they are used. Actually, there are two types of real-time systems: hard real-time system and soft real-time systems. In hard real-time systems, it should be it is very must that it should work on deadlines, because if it doesn't work on deadline, then there is a matter of life and death, right? So it's generally used on missiles and all. But soft real-time systems are satellites and all. Okay, those also requires output within a given deadline. But here, if deadlines are revealed, then there is no matter of life and death. So this was evolution of operating system, and depending upon the evolution of operating system, the different functionalities has